Okay, to wrap up Unit 7, we're going to look at basically what we use Lewis structures for. Lewis structures are two-dimensional drawings, models of how atoms are bonded to each other and how the electrons are involved in creating those bonds. And so now we're going to look at taking that a step further to look at, well, what does that say about the shape of the molecule? And ultimately we're looking at whether it's a polar molecule or a nonpolar molecule. And in the next unit we're going to look at, well, how does this, the shape and the polarity, how does that affect its properties? So that's kind of where we're headed with this. The next unit will be applying what we learned in this unit and seeing how that affects things like melting point, solubility, all those different properties that we observe about different substances. Okay, molecular geometry, when we talk about that, we're talking about the shape, the three-dimensional shape of a molecule. Okay, and the model we use to determine what its shape is called valence shell electron pair repulsion, Vesper, and it basically centers around one key concept, and that is that when you have pairs of electrons in a molecule, they are going to position themselves in a way that they maximize the distance between them. Okay, like charges repel, so this really makes sense that this would be the way the electrons would arrange themselves. They're going to spread themselves out so that they maximize the distance between them, and that's going to dictate what shape we see in the molecule. Electron geometries. This is referring to the arrangement of the electron pairs that are on the central atom. And it doesn't matter if it's a bonding pair or a lone pair, double bond, triple bond. We're not concerned. We're treating all of those the same. One bonding pair is one electron group. A lone pair is one electron group. A double bond counts as one electron group. Okay, and so these are the things that are going to spread themselves out or orient themselves to maximize their distance between them on the center atom. So we're still focusing in on the center atom just like we did with Lewis structures. And so the electron geometries, the basic ones, there are 6 basic ways that these pairs can orient themselves, or these groups can orient themselves. And that's this list that's right here. Again, based on the number of pairs or groups. And you can kind of visualize, get a kind of a visualization here with these balloons. Because if you were able to like hold the balloons at the ends so that your hand would be kind of the central atom, then these balloons, the way they're arranged, this shows you kind of a three-dimensionally what do these look like. All right, this is an example of a Vesper table. You have one, I have a link posted to one on the website, and you will be able to use that in the future and on the test. And so basically what I want you to do is to learn how to use this table. And the basic thing we're going to look at is you're going to pay attention to, all right, the first thing we'll look at is number of electron groups, okay? And again, we're including bonding, lone pairs. Each one of those counts as one. Okay, then, so it'll have, this is the electron geometry. That's based on the total number of electron groups. Then, in order to get to the molecular geometry, the difference between electron and molecular geometry is the geometry of the atoms themselves. How are the atoms oriented? So here, we're looking to see how did the bonding pairs orient themselves. And this is affected by whether we have lone pairs or not. Okay, so an example, and this is a nice table because it has some visual pictures here of the models as well. But so if I have 2 electron groups, and of course in that case, we're going to end no lone pairs, we end up with a linear geometry. Okay, they're in a straight line like that. Whereas if I have 3 electron groups with no lone pairs, I end up with this trigonal planar. So it's like this one is. It's flat, which is the planar part of the name, and trigonal meaning 3. Spread out, and you can see, as you would expect, they're spread out at 120-degree angles. Okay? If I have 3 electron groups and 1 lone pair, I have what they call angular here. Some tables you'll see this referred to as bent. Okay, those are two names for the same thing. And let's see if we can get some more pictures. Here is tetrahedral, and if no lone pairs, we get this tetrahedral shape like this. So we have 4 electron groups, no lone pairs. Then if we have 1 lone pair, we get what's called trigonal pyramidal. Okay, and you can see the lone pair, these are the lone pairs here. Their presence basically repulses these bonding pairs down. And so if you wanted to know what the shape would look like, you can kind of look at this drawing over here and just imagine, say, that top one were gone. So the trigonal pyramidal would just be this bottom piece here, kind of like a little pyramid. All right, and that's kind of the way that you're going to use the table. You're going to draw the Lewis structure. Then you're going to look at the table and match up number of electron groups, how many lone pairs do you have, and then just read the name of the geometry off of the table. Okay, so like I said, this table is very similar to the one that you have and will be able to use. Same information.